Here is something physicists agree on, and almost never say out loud. If you fell through the event horizon of a large enough black hole, the point of no return, the edge of the most destructive object in the universe, you would feel nothing. No jolt, no flash, no warning. The room around you would look the same. Light would still reach your eyes. Your coffee would still be warm. Crossing the border between everything and oblivion feels like nothing at all. Which raises a question that sounds like a joke, until you sit with it. If crossing feels like nothing, how would you know it hasn't already happened? Some physicists take that question completely seriously, because there is a calculation you can do on the back of an envelope. One number in, one number out, that seems to say we are inside one right now. There is a paper from 1939, written by the man who would later build the atomic bomb, proving that you could be sealed behind a horizon and never notice. And just last year, the most powerful telescope ever launched counted 263 distant galaxies, and found most of them turning the same way. 3 coincidences. By the end, you will have all 3. What they add up to is yours to decide. Start with what nobody disputes. Black holes are real. For half a century, they were an embarrassment. A prediction that fell out of Einstein's equations in 1915, which Einstein himself doubted could ever be physical. Nature disagreed. We have heard them collide in gravitational waves that rang through 2 detectors in America. We have photographed one, a ring of orange light around a shadow, 55 million light years away. And we have watched for decades as stars at the center of our own galaxy whip around something dark that weighs 4 million suns. Every black hole has the same anatomy. At the center, a singularity, a place where density runs to infinity and the mathematics of general relativity simply stops. Around it, an event horizon, a one-way surface. Space flows across it like a river over a waterfall. Inward is allowed, outward is forbidden, even for light. Now look at the universe we live in. It is expanding, space itself stretching, carrying the galaxies apart. Run the film backwards and everything converges, 13.8 billion years ago, onto a state of infinite density where the mathematics stops. A singularity. And because expansion accelerates, there is a distance beyond which light can never reach us. A surface wrapped around every observer. A horizon. Look at the 2 skeletons side by side. A black hole. A singularity, wrapped in a horizon that light cannot cross. Our universe. A singularity wrapped in a horizon that light cannot cross. The most exotic object in physics and the whole of reality, built on the same blueprint. Mainstream cosmology calls this a family resemblance and nothing more. But a resemblance like that begs to be tested. And in 1972, a physicist named Raj Pathria realized the test was almost embarrassingly simple. You don't need a telescope. You need a scrap of paper and 1 line of arithmetic. Here is the calculation. Carl Schwarzschild showed that any mass becomes a black hole if you squeeze it inside a critical size, its Schwarzschild radius. The formula fits on a postage stamp. Double the mass, double the radius. The Sun's is 3 kilometers. Earth's is 9 millimeters. So, take everything we can see. Every star, every galaxy, every cloud of gas, every speck of dust. Add the dark matter we can weigh but cannot find. The total comes out around 10 to the 53 kilograms. Feed that 1 number into Schwarzschild's formula, and out comes a radius of roughly the observable universe. Sit with that. The universe is not too big to be a black hole. It is not even close to too big. Everything we can see fits inside the horizon its own mass would make. When Pathria published that observation in Nature in 1972, the title said the quiet part plainly, the universe as a black hole. Now, every physicist reading this has an objection ready, and it is a good one. A black hole's singularity is a point in space, over there, at the center. The Big Bang was not over there, it was everywhere. It happened where you are sitting. But here is what general relativity actually says, and it is stranger than the objection. Inside an event horizon, space and time trade jobs. The singularity stops being a place you could point to, and becomes a moment. It sits in your future, the way tomorrow sits in your future, everywhere and unavoidable. Every path through a black hole's interior ends at the singularity, in the future. Now run our universe backwards. Every path through our past ends at a singularity too. The Big Bang, everywhere and unavoidable. The same object, just mirrored in time. Physics has a name for a black hole running backwards, a white hole. Nothing can stay inside it. Everything must pour out, an expanding flood of matter, pouring out of a singularity in the past. That is a white hole's interior. It is also a fair description of the Big Bang. The question is whether the resemblance survives detail. 33 years before Pathria, someone had already, accidentally, worked out the answer. In 1939, Robert Oppenheimer, 6 years before Los Alamos, sat down with his student Hartland Snyder to answer a different question entirely. What happens when a star dies? They built the simplest possible model, a ball of matter, perfectly uniform, no pressure. Then they let it fall. The outside behaves exactly as Schwarzschild predicted. The star shrinks, a horizon closes around it, and it becomes a black hole. But the inside is where the ghost lives. Inside the collapsing ball, Oppenheimer and Snyder found space-time stays smooth, uniform, and is described by precisely the same geometry that describes our whole universe, the one cosmologists call FLRW, the metric of a smooth cosmos evolving in time. To an observer inside the ball, physics looks ordinary. Nothing marks the moment the horizon seals overhead. The sky does not go dark. No alarm rings. They are cut off from the rest of reality forever. And they feel nothing. That is the structural coincidence, and it is exact. A universe-shaped interior is not something black holes might allow. It is what the first honest model of collapse actually produced. Flip it in time, and the construction becomes ours. A white hole erupting, with a smooth expanding universe inside. Indistinguishable from within from a Big Bang. That was Pathria's proposal. Half a century on, nobody has convincingly shown it can't be true. And it may run deeper than can't be ruled out. Nicodeme Popławski asks, what happens if you refuse to let the infinities in, using an old extension of Einstein's theory, where the quantum spin of matter twists space-time itself. Compress matter far enough, and that twist pushes back. The collapse doesn't crush to a point, it bounces. And a bounce, seen from inside, looks like a violent, accelerating expansion, uncannily like the early universe. In this picture, there is no singularity at the bottom of any black hole. There is a birth. Every black hole in our sky would be the outside of somebody else's Big Bang, and our Big Bang the inside of somebody else's black hole. Follow that logic and universes reproduce. Lee Smolin took it to its Darwinian conclusion. Universes that make many black holes make many offspring. It is elegant, it is published, it almost wins. So why isn't it the standard story? Because when you interrogate the coincidences, The first two start to talk. Take the envelope calculation. Our universe sits at what cosmologists call critical density, the knife-edge value that makes space flat, and you can show in 2 lines of algebra that any universe at critical density automatically matches its own Schwarzschild radius. The coincidence is real, but it may just be the flatness of the universe wearing a costume. Skeptics say, no new information. Believers answer, then why is it flat? The standard fix, inflation, was invented to explain exactly that. A bounce gets it for free. The deeper objection belongs to Roger Penrose, and it is about character. A real black hole's interior is not smooth. Infalling matter churns it. Tidal forces shred inward. The singularity is chaos. But our beginning was the opposite of chaos. The cosmic microwave background, the baby picture of the universe, is uniform to 1 part in 100,000. The smoothest thing ever measured. If the Big Bang were the inside of a real, messy collapse, the mismatch is glaring. The 2 singularities, Penrose argues, have opposite personalities. And the third coincidence? For years, claims that galaxies favour a spin direction kept dissolving on inspection. Duplicates in the catalogues, biases in the eye. When astronomers reanalysed the biggest sample in 2021, the signal vanished, consistent with random. The microwave background agreed. If the universe rotates at all, the odds against are 121,000 to 1. Then came the most powerful telescope ever launched, 2025. Lior Shamir points the James Webb's deepest survey at 263 spiral galaxies and counts. Roughly 3 in 5 turn the same way. In a fair universe, that lopsided account should be rare. But inside a rotating black hole, and real black holes rotate, space-time itself is dragged around an axis. Everything born inside inherits the spin. Maybe, or maybe our own galaxy's rotation subtly brightens galaxies turning against us. A bias, not a message. The patch of sky surveyed would hide behind a pinhead at arm's length. More data is coming. But mark the strangest part. That same year, cosmologists showed that a universe rotating once every 500 billion years, far too slowly for the microwave background to forbid, could ease the worst crisis in cosmology, the Hubble tension. The one anomaly this old idea predicts is the one cosmology suddenly needs. So weigh it honestly. What is known? Black holes exist, the Big Bang happened, and the 2 share a skeleton. The same equations, the same anatomy of singularity and horizon. It is known that everything we can see fits inside its own Schwarzschild radius, and that general relativity happily builds sealed interiors that look exactly like a smooth universe. Whoever designed this cosmos left the blueprints compatible. What is uncertain? Whether any of that is a clue or a pun, the envelope number may be flatness in disguise. The galaxy spins may be a bias that better data will iron flat, or sharpen into the first real crack in the cosmological principle. And what is open? Truly open, whether anything came before the Big Bang, a beginning from nothing and a bounce inside something, currently predict almost the same universe. Almost. A preferred axis, a faint rotation, a statistical fingerprint in a million galaxy spins. That is where the answer will come from, if it comes. If we are inside a black hole, nothing about your morning changes. The coffee still cools. The stars still rise. The only thing that changes is the address and the neighbours. The evidence is yours now, same as it is theirs. A beginning or a bounce? What do you think? And that is where I will leave it. And if there is a mystery you would love to see untangled, tell me. Until the next one.